Day 5, here we come, guys. So we're still in the same section. It's an 8-day section. So we are going to talk about the last and final way of solving a quadratic, which is to solve it by factoring. So still section 2.5. That's no different, but today our goal is to solve by factoring. Oh man, this is still fun. So solving by factoring and that lovely writing. I know my handwriting's bad, but it's especially bad again. So we technically already did this when we learned how to graph in intercept form. So when I gave you a function in intercept form, the first thing we did to graph it is set the factors equal to 0 to find our x-intercepts. The only difference is that these examples are not going to start off in intercept form. They're going to start off in standard form. So we have an additional step of having to factor it first using our factoring strategies and then set the factors equal to 0 to get our x-intercepts. Okay, so these examples, they're going to start off in standard form and we're going to set them equal to 0 in order to factor. So everything needs to be on one side of the equation. Factoring is really quick if the C term is missing. So when the C term is missing, factoring is the quickest way to get your answer. You could do the quadratic formula like we were doing yesterday, but factoring will be much faster to get your solution. And then let's just get right to it. Sorry, sidetracked. So let's do one. Let's go ahead and solve. So first example, x squared plus 3x minus 18, already set equal to 0 for us. So factoring a trinomial, I know it's been a little bit, but we definitely can't lose these factoring skills since they are the #1 skill I will teach you this year. If I had to choose one thing, it would be factoring. So for trinomials, we do our guessing and checking. The a value is 1, which also makes guessing and checking even easier. So we just have to try to find factors of negative 18, that'll add or subtract to positive 3. Think about that for a second. Pause the video if you want to do it on your own. And the winning combination is going to be 6 and 3. To get positive 3, I'm going to have a positive 6 and a negative 3. Positive 6 times negative 3 is negative 18, and 6 minus 3 is positive 3. This is now factored. To get the solutions, though, or the x-intercepts, we have to go ahead and set each factor equal to 0 and solve. If I solve the first one, I'm going to get x equals negative 6, and the second one, I'm going to get x equals positive 3. This is a very important relationship that will show up on things like the SATs, and that's the relationship between a solution and the factors. Okay? So it is important to note that relationship. Notice if the factor is a minus, then the solution is positive, and vice versa. If the factor is a plus, the solution is negative. You should be able to match those up and go back and forth between the two fairly quickly with mental math. So that's the first example. All right, second one, and we've got a total of 5 of these. If I gave you 2t squared minus 17t plus 45 equals 3t minus 5. So I have to set that equal to 0. Keep your a value positive always when factoring. It was optional with the quadratic formula, but with factoring, the a has to be positive, or else you're going to have to factor out a negative first, which is a waste of time. So I'm going to move everything to the left side of the equation. I'm going to subtract the 3t and add the 5. I'm going to get 2t squared minus 20t plus 50 equals 0 now. Another trinomial. Okay. If you're looking at this closely, you should notice that there is a GCF on this problem. GCF is still always the very first step of factoring. So we're going to factor out a 2, divide all of our terms by 2. And now our a value is 1 again. So it's not a super challenging factoring example, finding factors of 25 that add to negative 10. Technically, you might recognize this is a perfect squared trinomial. Even if you don't recognize that, you can still factor it by guessing and checking. So both factors will be identical, and they're both going to be t minus 5. T minus 5. Or you could write it as t minus 5 squared. But because both factors are the same, you don't have to set them both equal to 0. You're going to get the same solution. And if you set t minus 5 equal to 0, you're going to get t is equal to 5. So we only get one answer for this problem, but that technically is a repeated 0. That solution would count 2 times. You do not set this factor of 2 equal to 0, and that's because that 2 does not have a variable, so it does not impact the value of x, or your roots, or your x-intercepts. Okay, that GCF did not have a variable, so it will not impact your solution. Third example. Let's try 3 equals 12x squared. That's an equal sign. If I set it equal to 0, and I want to keep my a positive, so I'm going to move the 3 to the right. From here, another GCF. And there's only 2 terms. The only way I taught you guys how to factor a quadratic with 2 terms is if there was a GCF, or if it was one of our shortcut strategies, the differences of 2 squares. So I took the GCF out first, but this can still be factored more. This is a difference of 2 perfect squares. 4 is a perfect square, 1 is a perfect square, and it's a difference, it's subtraction. So that's going to factor into 2 binomials that are almost identical except for their signs. This is good review here. And I'm going to square root each of those terms to get 2x, 2x, 1, and 1. These solutions will be different. If I set 2x plus 1 equal to 0 and 2x minus 1 equal to 0 and solve each of those, the first one I would get negative 1/2, and the second one I would get positive 1/2 when you add over the 1 and divide by 2. There you go. The original problem, if you look back up here, the top, it was missing a b term. So another strategy on that one, like if I gave this to you on a test or a quiz and it was up to you on how you solved, I didn't tell you a specific method, then I probably would have solved that one by square roots because it doesn't have a b term. So I would have divided by 12 and square rooted both sides versus attempting to factor it. That's just another way you could have solved that example. All right, fourth one. 6p squared plus 15p plus 9 equals f of x. All right. Anytime I give it to you in function form with the f of x or the y variable, and you're trying to solve, you have to sub in 0. Because it's in function form, I could refer to these solutions as the zeros. Looking at the trinomial, pause, you should try this one on your own, but I'm going to go ahead and continue on with the solution. It does have a GCF of 3. And then I'm going to go ahead and try to guess and check that trinomial. The a value is not 1 this time, it's a 2. So a little more checking involved. Okay. Factors of a, which is 2, is just 1 and 2, so it's got to be a 2p and a 1p. And the factors of 3 are just 1 and 3, so it's either going to be 1 and 3 or 3 and 1. We're trying to get a b value of 5. So I want to put the 1 over here and the 3 over here, and everything's positive. I can double check that. If I do the outer and inner, I'd get 2p plus 3p, which is 5p. It does match up. I keep bringing down my 0 there. I don't want to lose my equation. Now that it's factored, set each factor equal to 0 separately and solve. First one, if you do quick mental math to solve that 2-step equation, p is going to equal negative 3/2. You would subtract the 3 and divide by 2. And the other solution, you're going to subtract the 1. If a problem is factorable, you'll notice with all these examples, you will never get an imaginary answer. Okay? Imaginary answers come from problems that are not factorable. Same thing with radicals. You won't ever get a radical answer if the problem was factorable. So if you can factor it, you will always get two distinct values. They could be fractions, but they will never be a radical, and they will never be imaginary. Okay. Last example, 0 equals 10x squared plus 25x. Okay, try it on your own, pause, and check to see if you get the same answer as I do. What I would like to point out about this one, oh man, that's an arrow, is that this example is missing the C term. And I mentioned earlier that anytime the C term is missing, factoring is definitely the quickest way to get your solution. Way faster than the quadratic formula, and I can't do square roots because it does have a B term. So the only thing I can factor out here with the two terms is a GCF. Factor out the 5x, which will leave me with 2x plus 5. Looking at the binomial in parentheses, 2x plus 5, that's no longer a quadratic, so you can't do anything else with it. This is already factored. All you could do is the GCF. To find your solutions, you're going to set each factor equal to 0. You technically don't need to take the 5 with it, but you can. So you have 5x equals 0, and you have 2x plus 5, oh my gosh, equals 0. Well, let's try that again. First one, if you divide by 5, you're going to get 0 as a 0. And the second one, if you subtract the 5 and divide by 2, you're going to get negative 5 halves. Okay, so two solutions. Anytime you factor out a GCF, and this GCF did have an x, notice, okay, it has an x there. If it has an x, you have to set it equal to 0. It's with the GCF doesn't have an x that you don't need to set it equal to 0. So 0 will always be a solution when the GCF has an x involved. Right, negative 5 halves and 0. That's the first goal of class, just reviewing factoring and using factoring as a way to get your solution. In the second half of class, we're going to really focus in on the types of solutions that exist with all these examples and how to know how many solutions exist without finishing a problem out. Okay, so let's go ahead and talk about the solutions. Oh man, that's supposed to say quadratics. Not recalibrating again. I've recalibrated literally 10 times already. I'm after school right now talking to myself in my classroom by myself. And I've literally recalibrated this thing 10 times while recording all these lessons. So I'm not doing it again. It's annoying me. You get to just deal with it. So solutions to quadratics. Remember, I can refer to these as solutions, roots, zeros, x-intercepts, all referring to x, but do all have a slightly different meaning in terms of what we're referring to in the form I give them to you in. Okay, so we already know that one way we can figure out the solutions is looking at the graph. Okay, so I could have a quadratic function that crosses the x-axis twice. Okay, so you're going to see two real solutions, two real x-intercepts. You could see a graph where the vertex is on it. Okay, the y of the vertex is 0, so it doesn't shift up or down. Okay, this technically has still two x-intercepts. Or sorry, I shouldn't say two x-intercepts. It has one x-intercept, but it still has two zeros. It's just that the 0 repeats. It counts twice. In the first example, it's two x-intercepts, two zeros. You can clearly see it matches up 2 and 2. It's this middle one that looks a little confusing. You're only going to see it cross the x-axis one time, so there's only one x-intercept, but the 0 counts twice. It's a repeated one. And the last one, something like this, when the a is positive and the y of the vertex is positive, or the a is negative and the y of the vertex is negative, this will have no x-intercept. Okay, it doesn't touch the x-axis. However, it has two imaginary zeros. Oh, man. That says zeros, clearly. Okay, so two imaginary zeros, or zero x-intercepts. So you can look at the graph as one way. The second method, which we learned way back in the first section before I left on maternity leave, you can compare the A value and Y of the vertex. I'm not going to rewrite this all, okay? You can write C, long night, C prior notes. I don't know if you guys can see the timestamp on my screen right now, but it's 5:48 on a Monday night. I'm really ready to go home, especially with this smart board right now. Okay, so I'm not going to rewrite all that down again. You already wrote it down in your notes one time. You can go back and try to reference them. Hopefully you're organized enough. So if they're the same sign, that's when there's no x-intercepts. If they're different signs, so they'll have two x-intercepts. And if the y of the vertex is 0, there'll only be one x-intercept, or a repeated 0. And the third case is no. Okay, so we're going to use something called the discriminant to figure out the solution. The discriminant is part of the quadratic formula, and it's the part that's underneath the radical, the b squared minus 4ac. So by examining this number, you should be able to predict how many solutions there are. It won't tell you what the solutions are, just how many will exist. So there's three scenarios. If the b squared minus 4ac is greater than 0, okay, so that means you have a positive number for b squared minus 4ac. If you have a positive number underneath a radical, you're always going to get two solutions. Okay, so when this happens, you're going to get two real solutions. But if the b squared minus 4ac is less than 0, meaning you have a negative number underneath the radical, so just think of negative underneath a radical, that means you're going to get imaginary. So you're going to get two imaginary solutions, two imaginary zeros. And you would visually see no x-intercept on the graph. In the last case, if you get b squared minus 4ac is equal to 0, so you get 0 under the radical, if you were to do the whole quadratic formula out, it's plus or minus the radical, and you can't have a positive 0 and a negative 0. They're the same thing, so that's going to lead to a repeated solution. Okay, so that would be one real solution, but it counts twice. So it would still technically have two zeros, but it would be one distinct value. So we're only going to do one example of this. So for this example, we're going to determine the number of solutions. And it's got to be in standard form equal to 0, just like it would have to be if you were to use the quadratic formula. So just looking at that, it's in standard form, it's equal to 0 already, so we don't have to move anything from side to side. And I'm not going to do the whole formula, so I'm not going to do the whole x equals negative b plus or minus. I'm not going to do all that. I can figure out how many answers there will be by just doing the b squared minus 4ac. Putting the b squared in parentheses because it's negative, minus 4 times a times c. That'll give me positive 36. Then when I multiply the 4ac, I'm going to get negative 36, which is 0. So the discriminant is 0. Okay, this is the discriminant right here, the value of it. That does not mean that there's no solution. If we just look at the list we created, when the discriminant is 0, that actually means there is one real solution. There's one x-intercept, or a repeated 0. A lot of students will confuse the discriminant of 0 meaning that there are no solutions, but not the case. Now, if you wanted to actually find what the solution is, then you'd have to do the whole formula or attempt to factor that. But you would not be able to find the solution without doing more. That just tells you how many. Another tidbit about the discriminant. If the discriminant is a perfect square, and I normally mention this when I teach factoring, but because I'm not here, it's something that I did leave out. If the discriminant is a perfect square, so 1, 4, 9, 16, etc., then the quadratic is factorable. Because if you get a perfect square under the radical, it's going to come out of the radical, and you won't have an answer with a radical or an imaginary number in it. So that means you could have factored it. It is factorable. So if you're sitting there guessing and checking, and you're like, nothing is working, and you're like, well, maybe it's not even factorable. If you wanted to do the discriminant real quick, throw in the a, b, and c into b squared minus 4ac, and you get like 20. Well, 20 is not a perfect square. That means that quadratic is not factorable. Stop wasting your time and trying to factor it, and you can just say that it's not factorable. And if you had to solve it, then you would need to use another solving strategy, because factoring won't work. All right. So you guys are going to get a summary. Okay, so this is a summary of all the different ways of factoring that you can look at and use to help you. So remember, when you're solving, you're trying to find the x-intercepts, the zeros, or the roots, depending on the context of the problem. And it goes through each. The part in bold is when you should use that method, so when one method would be better than another. So for factoring, if you can quickly find factors of a and c that'll combine to b, then I would try to use factoring. I would also use factoring when the c term is missing. And it's always easiest when the a value is 1. All right, and then there are steps on how to factor and what you do with factoring to get the solution. The square root method, you solve when there's no b term or it's in vertex form, and then again, it tells you how to do it. Number 3 is something that we used to teach in the curriculum, but we cut out. You did learn how to complete the square, but you learned how to complete the square as a way of rewriting from standard form into vertex form. Well, you could also use completing the square to solve, because once you get it into vertex form, then you can solve by square roots. So you can kind of combine methods 2 and number 3. So we didn't do method number 3 as a solving strategy. We just used it as a rewriting strategy, but it is a possibility. If you rewrite it in vertex form, then you can solve by square roots. And so I left it on there just in case you're curious. And the last method, the quadratic formula, which can be used to solve any quadratic equation as long as you get it in standard form and equal to 0. There's the formula. And then it also just reminds you about the discriminant, which is part of the formula that we just discussed, that can be used to predict the amount of solutions. That's it. That's pretty much all I have to teach you guys about solving. To give you an idea of what we're going to be doing the last 3 days of this section, tomorrow you guys are going to be working on more real world, solving in the real world. It's going to be a mixture of the quadratic formula type questions, vertex type questions, specifically looking when something's going to hit the ground. So you have to read the question carefully and really think about what you're asked, what you're being asked. Okay? Some of them, the formulas will be given to you. Some of them you won't. If you're trying to just solve for a random x value, use one of these new solving strategies: factoring, quadratic formula, solving by square roots. If you're asked to find a maximum height, the highest, the most, the least, remember that that is referring to the vertex. You don't use anything that we've just been talking about. You go back to a few weeks ago, and you would use your vertex formula, which is negative b over 2a, and you use that to answer the question. So really read the question, think about, am I finding the vertex, or am I finding just another x value on part of this graph? If it's just another x value, then you do what we've been doing the last few days. But there are a couple of vertex examples thrown in there to make sure that you remember how to do those. The next day, you guys are going to work on just a solving all method type 3. So it's going to be a mixture of all of these methods, and some of them it's going to be up to you as to which strategy you choose, and then others you're going to have to solve a specific way. And then the last day of this section, you guys are going to have a slightly longer quiz, which will count double. So it's going to be longer than just like our typical 3 to 5 question quiz. You'll have most of the period to work on it. There are a couple other things that you're going to do that day, including one example that I will post in a different separate video, but most of the period will be the quiz. And that's it for solving. We have one section after the next 3 days of solving, and then we're finishing out the quadratic unit. We're going to start unit 3, and then I should be back in the middle of unit 3. I'm going to try to record some of the unit 3 videos, but I might stop with quadratics just depending on how much time I actually have to get these videos recorded. Talk to you guys later. I'm going to do one more lesson tonight before I go home.